Did you know the Sun is classified as a G-type main sequence star, also known as a yellow dwarf? It shines brightly due to the nuclear fusion happening in its core, where hydrogen atoms are converted into helium. This process releases an enormous amount of energy, which travels outward through the Sun's layers. By the time this energy reaches the surface, it radiates into space as sunlight. This light and heat are crucial for life on Earth. Also, did you know the Sun is incredibly massive, containing 99.86% of the total mass of the entire solar system? Its gravity is so strong that it holds all the planets, moons, and other objects in orbit. Without the Sun's gravitational pull, the solar system would not exist in its current form. This gravitational force also influences the orbits of distant objects like comets and asteroids. It's the central anchor point for our entire solar neighborhood. Did you know the Sun's outer atmosphere, called the corona, is much hotter than its surface? While the surface temperature, photosphere, is about 5,500 degrees Celsius, 9,932 degrees Fahrenheit, the corona can reach over 1 million degrees Celsius, 1.8 million degrees Fahrenheit. Scientists are still studying why the corona is so much hotter than the surface. The corona is visible during a total solar eclipse as a bright halo around the Sun. It's also the source of the solar wind that streams out into the solar system. Also, did you know the Sun will eventually exhaust its hydrogen fuel and evolve into a red giant star? In about 5 billion years, it will expand significantly, possibly engulfing the inner planets, including Earth. After this phase, the Sun will shed its outer layers, leaving behind a hot core known as a white dwarf. This white dwarf will gradually cool and fade over billions of years. This transformation is a natural part of a star's life cycle. Did you know the Sun's magnetic field is incredibly complex and constantly changing? It extends far beyond the Sun, creating the heliosphere, a vast bubble that protects the solar system from cosmic radiation. The magnetic field also causes sunspots, which are cooler, darker regions on the Sun's surface. These sunspots can be larger than Earth and are associated with solar activity such as flares and coronal mass ejections. The magnetic field's behavior influences space weather and has an impact on Earth's magnetosphere. Also, did you know the light from the Sun takes about 8 minutes and 20 seconds to reach Earth? This means when you see the Sun, you're looking at it as it was over 8 minutes ago. This light travels at a speed of approximately 299,792 kilometers per second, 186,282 miles per second. The distance between the Earth and the Sun is about 93 million miles, 150 million kilometers. This vast distance is why sunlight takes time to travel and illuminate our planet. Did you know the Sun's cores were nuclear fusion reactors, reaching temperatures of about 15 million degrees Celsius, 27 million degrees Fahrenheit? The intense pressure and heat cause hydrogen atoms to collide and fuse into helium, releasing energy in the process. This energy then moves outward through the radiative and convective zones. It takes thousands to millions of years for this energy to travel from the core to the surface. Once it reaches the surface, it escapes into space as sunlight. Also, did you know the Sun has an 11-year solar cycle characterized by varying levels of magnetic activity? During the solar maximum, the Sun has many sunspots, solar flares, and coronal mass ejections. These activities can impact space weather and cause disruptions to satellites and power grids on Earth. In contrast, the solar minimum has fewer sunspots and less solar activity. This cycle affects not only space weather but also the climate on Earth to some extent. Did you know the Sun plays a vital role in sustaining life on Earth? It drives the climate and weather systems by providing the necessary heat and energy. Photosynthesis, the process by which plants convert sunlight into chemical energy, relies on sunlight. This process produces oxygen and forms the base of the food chain. Without the Sun, Earth would be a cold, dark, and lifeless place. Also, did you know studying the Sun helps scientists understand other stars and the broader universe? By observing solar phenomena like solar flares, sunspots, and the solar cycle, researchers gained insights into stellar behavior. These studies also improve our understanding of how stars evolve and interact with their planetary systems. The Sun serves as a natural laboratory for learning about astrophysical processes. This knowledge can be applied to studying distant stars and galaxies. Did you know that the sun's gravity is incredibly strong? It is about 28 times stronger than Earth's gravity. This means if you weigh 100 pounds on Earth, you would weigh 2,800 pounds on the sun. The sun's powerful gravitational pull keeps all the planets, moons, and other objects in the solar system in their orbits. Without the sun's gravity, the solar system would fly apart. Also, did you know that the name sun comes from the Old English word sun, which is derived from the Proto-Germanic word sonnen? This name has been used for thousands of years across different cultures. In Latin, it is called sol, which is why terms like solar system are used. Many ancient civilizations worshipped the sun as a god. The sun is central to our lives, providing light and energy to Earth. Did you know that the sun is about 4.6 billion years old? Scientists estimate its age by studying the oldest objects in our solar system. This means the sun was formed from the gravitational collapse of a region within a large molecular cloud. Over billions of years, it has gone through different phases, but it is currently in its stable phase called the main sequence. It still is about 5 billion years before it turns into a red giant and eventually a white dwarf. Also, did you know that the sun is actually a pretty average-sized star compared to others in the universe? Many stars are much larger and more massive, known as supergiants. On the other hand, there are also many stars smaller and cooler than the sun, called red dwarfs. The sun falls right in the middle, which is why it's classified as a G-type main sequence star or G dwarf. Its average size is just perfect to support life on Earth. Did you know that while the sun looks incredibly bright to us, it's not the brightest star in the universe? Stars like Sirius, the dog star, shine much brighter from our perspective due to their proximity and intrinsic luminosity. If we place Sirius where the sun is, it would appear significantly brighter. However, there are stars like Rigel and Betelgeuse that are even more luminous but much farther away. The sun's brightness is just right for life on Earth to thrive. Also, did you know that the sun is one of the few stars we can study in great detail? Most stars are so far away that even our most powerful telescopes can't see them as anything more than points of light. Because the sun is so close, we can observe its surface, measure its activity, and learn a lot about how stars work. This makes the sun a crucial object of study for astronomers. What we learn from the sun helps us understand other stars in the galaxy. Did you know that the sun's surface temperature is around 5,500 degrees Celsius, 9,932 degrees Fahrenheit? This is the temperature of the photosphere, the visible surface of the sun. However, the sun's core is much hotter, reaching temperatures of about 15 million degrees Celsius, 27 million degrees Fahrenheit. These extreme temperatures are due to nuclear fusion, where hydrogen atoms combine to form helium, releasing vast amounts of energy. This energy eventually makes its way to the surface and radiates into space as sunlight. Also, did you know that if the sun were the size of a typical front door, Earth would be about the size of a nickel? This comparison helps us understand just how large the sun is compared to our planet. Despite the sun being about 93 million miles away, its immense size allows it to provide enough light and heat for life to thrive on Earth. Its diameter is approximately 109 times that of Earth. This immense size is what allows the sun to have such a profound impact on our planet. Did you know that the sun rotates, but not all parts of it rotate at the same speed? This phenomenon is called differential rotation. The equator of the sun rotates once approximately every 24 days, while the poles take more than 30 days to complete a rotation. This difference in rotation speeds can lead to complex magnetic field interactions, causing solar phenomena like sunspots and solar flares. Understanding the sun's rotation helps scientists predict solar activity that can affect Earth. And if you like this video, please leave a comment, like and subscribe. It helps the channel to grow and encourages us to create more videos with interesting facts which you may have or haven't ever heard about. Thank you and see you next time.